Okay, which of the following are equivalent to secant squared alpha minus 1? In case this is your first time, I don't think it is, but in case it is the first time seeing this notation, it threw me off when I was in school. This means secant alpha, which is just another variable, like x. It means secant alpha being squared. Okay? I don't know if that's going to really apply here, but every time I see that I think back to when I was in school. Now, we have these Pythagorean identities that can help us out. You can rearrange them. They're equations. They're statements of equality, so you can subtract 1 from both sides if you want, and I do actually, because look, I can match this up so I have something to replace if I just subtract 1 from both sides. There we go. Tangent squared theta, that's secant squared theta minus 1. So now I can make a replacement to try to start simplifying this thing. This top part is just tangent squared alpha. I hate drawing the Greek letters because I'm bad at it. Over, and then we still have sine alpha in the denominator. In case you're if you're not sure where to go from here to simplify this, this is the same thing as tangent squared alpha divide by sine alpha, and then put tangent in terms of sine and cosine, so you get sine squared alpha over cosine squared alpha, and then flip and multiply. If you're dividing sine theta, that's the same thing as multiplying by 1 over sine. I said theta, but it's alpha. So we have sine squared up here, so 2 sines multiplying. Let's cancel one of those out with what we have over here. So we're left with sine of alpha over cosine squared alpha. That doesn't match up with anything we have here, so let's think about how we could rearrange this too. We could get a tangent out of this if we just have sine over cosine. I'm dropping the alphas just because my hand's hurting here. Right? It's like I pulled one of the cosines off to the side. This is tangent. And then this is secant because it's the reciprocal of sine. So tangent times secant, this is secant alpha times tangent. That works. The order you multiply doesn't matter, so that's our winner, okay? We simplified this whole thing. It turns out to be this that I've circled here in red. So we're supposed to simplify tangent squared theta plus 1 over secant to the third theta. Look, tangent squared theta plus 1, that's the same thing as 1 plus tangent squared theta. The order you add doesn't matter. So we know the top is going to simplify to make secant. We can make that substitution. The top is secant squared theta because of this line right here. And the bottom is still secant to the third theta. And so if you have x squared over x to the third, that makes 1 over x, right? But instead we have secant to the second, secant to the third, so that makes 1 over secant theta. And now, not squared, because 2 of these and 1 of these canceled out. So 1 over secant theta, secant's the reciprocal of cosine, so the reciprocal of the reciprocal, that brings us back to cosine.